Hi, it's Mr. Anderson, and this is AP Physics Essentials, video 123. It's on electromagnetic radiation. Newton had shown that if you shine white light into a prism, it breaks it apart into its different colors. And another scientist wanted to know, is there any relationship between different colors of light and the temperature? So William Herschel took a thermometer and put it in the purple light, and then the blue light, and the green, and in the yellow, and in the red. And he wanted to figure out where were the different temperatures dependent upon color. But he wanted to have a control in this experiment, so he put another thermometer right off on this side just to judge the room temperature. And what he found, surprisingly, is that that was the hottest temperature of all. So he really discovered was infrared rays. And so those are rays that we can't see but generate a lot of heat. And so electromagnetic radiation, we only see a small sliver of that called visible light. But there's a whole bunch of other electromagnetic radiation out there in the universe. And we can put it on a spectrum and measure it from the really low, small wavelength to really long wavelengths up to kilometers in wavelength. And then on the other direction, we're going to have increasing frequency. So as we increase frequency, we're going to decrease that wavelength. As we increase frequency in electromagnetic radiation, we're also increasing the amount of energy that those waves have. And so if we start with really high energy, we would have gamma rays, then X-rays, then infrared, and then visible light. So you can see that we're just seeing a small sliver of electromagnetic radiation. We then move into ultraviolet, finally into microwaves and radio waves. And so inside this room right now, I have visible light, but there are also radio waves here. That's how you could pick up a radio signal or a TV signal. But I also probably have microwaves in here as well. Hopefully I don't have too many gamma rays in here right now. But if we put them along a spectrum, they're going to decrease in wavelength as we move towards those gamma rays. To give you a sense of scale, radio waves are going to have wavelengths around the size of a building, but gamma rays down around the size of a nuclei. And there's this inverse relationship. So as we increase wavelength, we're going to decrease the amount of frequency. And so as we increase frequency, we have higher amounts of energy. So which one would you rather be exposed to? These ones with long wavelength, really, really low frequency, low energy. The ones on the right side are going to be able to damage cells, ionize cells, cause damage to the cells itself. And so did you learn to just make qualitative comparisons based on wavelength and frequency of electromagnetic radiation? I hope so, and I hope that was helpful.